Malware is the invisible enemy of our digital age. Sometimes it's even hiding in plain sight, and you just don't see it. You know that software you downloaded that you thought was perfectly okay? Well, maybe not. There could be something else inside. From harmless pranks in the early days of the internet to today's billion-dollar ransomware attacks, ransomware and malware has evolved, and it's not done yet. In this video, we're going to take a look at the evolution of malware, from where it started, what it looks like now, and where it could be going. And if you stick around until the end, you'll learn what you can do to protect yourself against it. Bear in mind that there are far too many types of malware to cover in this video, so I'll just summarize here and make some broad generalizations in the interest of simplicity and time. So if your favorite example of malware isn't mentioned, I beg your forgiveness. With that disclaimer out of the way, let's start with malware of the past. So we're going to take a look at how malware used to be. Now, it's not that these things don't exist anymore, and they still do exist in various forms. We just don't see them quite as much as we once did. Back in those days, malware was mostly experimental, or it was just mischief. It wasn't about money. It was really more about curiosity, ego, and just disruption. So if a guy could just make a name for himself by doing something on his PC and then seeing that it showed up on the headlines, that was reward enough in and of itself. So let's take a look. Where did all this stuff start? Well, the original term that was used for all of these things that most people first became familiar with was the term virus. So a virus basically is malware that is attached to a file that needs user interaction in order for it to spread. And one of the biggest examples of these, although it certainly wasn't the first, was something known as the I love you virus. In this case, and this was back in the year 2000 that this came out and really did its damage, but it did billions of dollars in damage, between 5 and 10 billion, according to some estimates. Basically, you got an email that came in and it said, I love you, or love letter, or something like that. It had a file in it, and if you double clicked on it, it looked like it was going to be a text file. It turned out it was a Visual Basic script, which means it was an executable. It would run on your system, and then it would go start writing itself over a lot of different files, a lot of JPEGs and other files like that. So again, it required some user interaction, but it was damaging files on your system. Nobody was making any money, just doing some damage and making some notoriety for the person who did it. Another type is something we call a worm. Now, the difference between a virus and a worm sometimes gets a little bit dicey, but the basic definition of a worm is it's self-replicating malware that spreads across networks. So it doesn't require any user intervention. It can just spread itself. So the really classical example, and really the first one that most people became aware of, was called the Morris worm. And it was written by a guy whose last name was Morris. It came out in 1988, and it was designed to basically take a look at multiple vulnerabilities that were in systems in that day on what was known as the ARPANET, which was essentially the predecessor to today's internet. And it would go probing around, seeing which systems had these vulnerabilities, and if it did, it would plant itself on those. The problem is there was an error in the replication mechanism, and it would replicate itself to the same systems over and over again. And once this started going out, it became viral in terms of the way it spread. So this worm now was going from one system to the next, and then back to the first one, and then all of those others were going back to the first one, and so on and so forth. So this then basically took down large portions of what was the predecessor to the internet. And it was something that maybe wasn't intended to be malicious, but it ended up being malicious in the long run. Another example of these are called Trojan horses, or Trojans for short. You know from Greek mythology with the story of the Trojan horse. Well, this is the same sort of thing. It's something masquerading as a legitimate software to trick users. So one of the biggest examples of this is called Zeus. It was a banking Trojan, came out in 2007, and it was designed basically to do credential theft. It did something that's known as a man-in-the-browser attack. So it puts a presence itself in your browser. So when you go to your bank's website, it's sitting in there, and it basically sees everything that you're typing as well as everything that's going back to the bank. And it's right there in the middle, and therefore it can change transactions. It can see your sensitive information and things like that. So this was a big one. Again, cost a lot of money. Again, in this case, it's masquerading as legitimate software, but in fact has a deep-seated problem with it. Other types that were really less common, and we really don't see nearly as much of these anymore, would be things like boot sector malware. Well, why do we not see this? Well, think about it. We don't boot from floppies, and that's how most of these things were spread in those days. There was one called Michelangelo that came out in 1991 that worked on the disk operating system, DOS, if any of you even remember that one anymore. So it would be on the boot sector of the floppy drive, and then whenever you inserted it into a system and booted up, then this malware would implant itself on your system. So there were examples of that, plenty of those back in the day. We don't use floppies so much, so we don't see those anymore. Another thing we don't see so much of anymore, but was a big deal at one point, macro viruses. So macros are things that could be embedded into Office documents, like Microsoft documents like Word and PowerPoint and things like that. And these things would basically take advantage of the fact that you could embed code into those. You could have scripts or macros that were in a document. Most people thought of a doc file as just being something that was read-only. They didn't really consider the fact that actually code could be inside that as well. Well, there was one called Concept, and it was called this because it basically was a proof of concept. Came out in 1995, and basically when you open this Word doc, it would just put up a message that says, "That's enough to prove my point." And a lot of people are like, what in the world does that mean? Well, of course, did prove the point. And later, in 1999, Melissa came along, and not the person, but a Word doc, one of these macro viruses, that was an attachment to emails that then would send a copy of itself to the first 50 contacts that you had in your address book. So this one was kind of a combination macro, but it also had worm-like characteristics. And that's another thing to remember, is that some of these things cross barriers and are hybrids of these. One more I'll talk about is called a rootkit. And a rootkit was something that would basically hide malicious activity deep and persistent into the operating system itself. So this was one that you might not see any signs of it, but it's gotten into the operating system, and now it's changing the way everything on your system operates. So back then, in summary, malware was loud and often visible. It crashed systems. It was showing strange messages and things like that. We don't see as much of that anymore, basically because we've got better operating system security, where the operating system vendors have done more to look for these kinds of things and put in some protections. We've got better malware detection tools and more use of multi-factor authentication, so that if information is stolen, then if we have MFA in place, it's going to be harder to exploit some of those things. Okay, now let's take a look at malware of the present. What are we seeing? The kind of stuff today are the major threats. Well, we continue to see some of those things from the past, just maybe not quite as much these days, although some of them still carry forward for sure. But modern malware is smarter, it's stealthier, and above all, it's profitable. So it's not just about notoriety and trying to throw a monkey wrench into the system. It's about trying to see if I can actually profit from this. So that ends up being a major motivator for one of the major types of malware we see these days, and that's ransomware. With ransomware, there's basically two types that you can think about with these. One type of ransomware is basically, here's your data, I've got your data, and I'm not going to give it back because I just encrypted it, and if you want to get it back, you got to pay me, and then I'll give you the key, then you can have your data back. That's one type. Another major type of ransomware is basically, I've got a copy of your data, and I'm about to give it to the rest of the world. In this case, I'm going to extort you for money in order to keep me from telling the rest of the world whatever your sensitive data might be, which might be the secret sauce for your company. So two different types. One of the most famous examples, or infamous if we want to think of it that way, examples of ransomware was a thing called WannaCry. And that's in fact what you wanted to do if this hit your system. It hit in 2017, targeted a lot of hospitals, but it could hit other systems as well. And basically what happened in this case is it would go and say, I've got your data encrypted, and if you want it back, then you're going to have to pay us. And in fact, it cost organizations, estimates are anywhere from 4 billion to 8 billion worldwide until they finally put an end to this one. And there's an interesting story behind that you might want to research. Another type of malware that we're seeing an uptick on these days lately, in fact, this came to us from the IBM X-Force Intelligence Index, that there's a thing called info stealers. Info stealers are, just as their name implies, they are trying to steal things from you. And the thing they're trying to steal is info, like your password. So this is malware that sits on your system. When you go to type in your password, it's making a copy of that, and then it sends that copy off to the attacker. Another thing it might try to get, in addition to passwords, it might try to get personally identifiable information about you. Maybe it looks on your system and sees your credit card number or your government ID number or your name and address and things like that. And that information then is sent to the attacker. They can then use that to get credit in your name, open a credit card or things like that. Or if it's a business, they could be stealing trade secrets and things like that. So another one, and this, like I said, we're seeing a rise on this type of malware. Finally, in this space, actually not finally, but another category is a RAT, a remote access Trojan. So I talked about Trojan horses in the past. Well, we still have Trojans. Now we see a lot more of them and a lot more damage being done from these kinds of things called RATs. A RAT is something that takes control of your system, but it's remotely accessible. So it's a remote access Trojan. In other words, you download the file on your system, or it gets implanted on your system by something that you've done, most likely. And in that case, the bad guy now has complete control of your system remotely. So he can see whatever it is you type, whatever it is that's on your screen. If it's a mobile device or a laptop, can turn the camera on and look at you, can turn the microphone on and listen to everything you say, can track your comings and goings by checking the GPS. It's very, very invasive, and it's very, very difficult in these cases to deal with some of these. One of the most pernicious examples of this is called Pegasus. This is one that dealt with a lot of journalists who were basically being stopped from being able to do their job because their systems were being infected by this mobile rat that was going around and controlling all kinds of things. Very, very sophisticated. Not all of them are that sophisticated, but many of them are. So this is one we really deal with a lot, and the consequences are devastating. Internet of Things. With IoT, essentially everything becomes a computer, and every computer can be hacked. So what that means is everything can be hacked. That's the world of IoT from a malware perspective. And there's one particular example of this called the Mirai botnet that basically was a collection of IoT devices. All of those things like security cameras, DVRs, things like that you may have in your home. And these things were all infected with malware, this Mirai malware, and they were collected together and put into a botnet. So that means you have lots of these devices all over the world, and then you collect them and you have them perform a denial of service against whatever your target is. So they all start sending information into a system and can basically take it down. At the time, the largest distributed denial of service attack we'd ever seen on the internet came from Mirai botnet. So it was able to do a lot of damage. And the thing is, the people that have these devices, you've got your DVR, it still works. You don't know that you're in fact basically an accomplice to attacking other people's systems. And then of course, if we're talking about the present time, you can't talk for too terribly long until you start talking about cryptocurrencies. So if there's cryptocurrencies, then guess what? There's money. And if there's money, bad guys will go to where it is. So there is a type of malware called a cryptojacker. You know that crypto mining is a way that people are able to make money. So what if they can silently hijack your hardware and then mine cryptocurrency, basically draining performance and power off of your system? So basically, they're using you and they're getting the profits, and you end up losing and they win. Okay, there we have the present, the kind of malware that we're mostly seeing these days. Now, we'll take a look at the future. Now here, we've got to look into the crystal ball. And nobody has a perfect crystal ball, so this is anyone's guess, but it seems like it'd be a safe guess to say that that future is going to have something to do with AI in large extent, because AI is really starting to launch into everything that we're seeing these days. So, for instance, the next generation of malware is already forming, and we're beginning to see some of that. For instance, AI-augmented malware will adapt in real time, evading defenses and planning attacks intelligently. One example where AI could be involved is in the creation of malware. So imagine this case where you've got basically a description of a vulnerability. We call this a CVE, Common Vulnerabilities and Exposures Report. That's a formal way that we describe some of these vulnerabilities in systems. And if I could feed that into an AI and have it write the exploit code that took advantage of that vulnerability. Well, in fact, there was a study that showed that the GPT-4 model in 87% of cases was able to do exactly that. So that's with the GPT-4 model today. The models of the future certainly will be more sophisticated and more capable of taking that and doing even more. So that's one aspect, is in the creation. How about in the execution of the malware attack? In this case, now there's a lot of different steps that go along with this. One of them is the decision, trying to decide what is it that I'm going to try to attack in the first place, and what kind of attack am I going to try to run? What are going to be the capabilities of that attack? So we could also get it involved in targeting, figuring out what are the soft targets that are out there, and ultimately using its intelligence to do evasion, to make it harder to find. We've had, even in the past, this stuff called polymorphic malware, where whenever it would replicate itself, it would also change over time. And that made it harder for antivirus tools to detect because the signatures were changing. The way the malware actually looked on the system was ever so slightly different. An AI-based system could be a lot smarter in doing that sort of stuff. So the potential here really is enormous. Now, another type of thing that might be involved that would leverage AI is using something called a deepfake. A deepfake is where the AI generates a realistic sounding version of your voice or someone else's voice or their image. And maybe imagine this, getting a call, a voice message that sounds exactly like your boss and tells you to do certain things. So this is basically another type of malicious software that's generating this and maybe starts combining with some of these other capabilities. And we see a hybrid version that is far more sophisticated, far more difficult to detect, and could do devastating damage. Okay, that's what we think AI might look like in the future. So we'll park that over there for right now. Now you need to live in the present and figure out what you need to do to stay safe. What actions do you need to take in order to keep from being a victim of all of this? Well, one of the most important, and I emphasize this on a lot of these videos, is keep your system patched. Keep it up to date with the latest software, because a lot of times what these malware examples are doing is taking advantage of vulnerabilities that are in the operating system, applications, databases, all this sort of stuff. And the vendor may have provided a patch, and if you haven't applied it, then the bad guys know how to take advantage, and then the race is on. So you need to make sure you're up to date with their software. You need to train yourself, and if you're running an organization, train your employees as well so that they know what kinds of behaviors they do that contribute to making the problem worse. That is, downloading untrusted code and doing those kinds of things. So make sure that everybody's up to speed on what malware is and the various types. Use the tried and true antivirus and now the newer class of endpoint detection and response tools. Depends on which operating system you're on as to how effective some of these things will be, but there's something certainly to keep in your back pocket. Some of these are better than others, some based on signatures. The more modern ones are based on behaviors, and they're more adaptable. So these things can also help. Super critical here, make sure you have a backup of any important data. You have to assume that failure will occur. And if you have a backup, then the failure is not catastrophic. In that case, you can restore from backup. Also make sure that your backups have not been infected by whatever malware is out there. So very important to have that kind of capability. Another one, especially on desktop systems, I think, is to limit the access that the users have. Limit admin access. If an end user using a workstation doesn't really need admin access on that system, don't give it to them. Give them a lower level of privilege so that when they go and try to do certain things or malware is running under their account, it won't have the ability to do a lot of damage because they're running just as a regular user, not as an administrator. You can use firewalls, personal firewalls essentially that run on the system itself and look and see what traffic is coming in, and maybe more importantly, some of the data that's being exfiltrated out of the system, and also network level firewalls that can look and see the behaviors. When we talk about these self-replicating type of viruses and worms and things like that, we can detect those kinds of things. And then if you can't see it, you can't secure it. So a security information event management system that gives you the overall view of the whole system and gives you that perspective so that you know what's happening. So now we've taken a look at malware, malicious software, past, present, and future. Where is all this stuff going? Well, it started off basically as pranks, then it's moved to profit, and soon potentially cyber weapons. As it evolves, we've got to evolve our defenses. So, bottom line, stay curious, stay updated, and most importantly, stay safe.